really pleased to make a transition now to experimentation. Elena Grewal is here. Elena is a data science manager at Airbnb, another Bay Area startup, a little further along than Trifacta, I guess. Some of you mid-students probably met her last night. Is that right? Yes. Elena leads a team of data scientists responsible for the online experience and online travel experience. Her team collaborates with the product team using experimentation and descriptive analysis to design and optimize the site, in addition to validating future product plans and inspiring those plans with exploratory analysis. The team is also responsible for data-driven products such as pricing suggestions and search ranking algorithms. Prior to working at Airbnb, Elena completed a doctorate in education at Stanford, where she built predictive models of friendships in school. Please join me in welcoming Elena.
Great. So first of all, thank you so much for inviting me to speak, for the nice introduction, and for organizing this wonderful dialogue. It's really a pleasure to be here. So as Anna mentioned, I'm a data science manager at Airbnb. For those of you who don't know, Airbnb is an online marketplace for accommodations, so people can list their homes and other people can stay there. And I joined Airbnb about 2.5 years ago, and over that time period, the company has experienced incredible growth. So to put this in context, when I started, our team was 5 data scientists, and now we're 25. And so what I want to talk to you guys about is how we've used data to guide that hockey stick growth, and in particular, how we've used experimentation. And so one of the themes of my talk will be that things are not always as simple as they seem. And so I think another thing that comes out of that is how important it is to have data scientists on your team so that you know that you're making the right decisions with the data that you're being given. So again, just to refresh, Airbnb is an online marketplace for accommodations. This is the homepage of our website. So you come to our website and you can put in where you want to go, the check-in and the check-out dates. And then after you do that, you are shown listings where you could stay. So displayed on a map, here are some listings. You can click onto a listing now, and you'll get more information about the place. And if it looks good to you and it's available for those dates, you can then request to book the place. And so that's really how the website works if you're a guest coming to the site. So we have a lot of different types of offerings on Airbnb. It's an online marketplace. We don't have guidelines for specific types of places, and people take many different kinds of trips. So you could be staying in an apartment for a night. We also have a number of unique listings, which are pretty neat, such as castles. And at its heart, Airbnb is also a global community. So it's more than an online marketplace. It's about connecting with people, staying in their homes. And there's really both an online component and an offline travel component to it, which is very unique. It's a part of this kind of idea now of the sharing economy. And there are many other companies now that are a part of this. And it presents a really interesting and new kind of ecosystem to study as a data scientist. And in particular, some challenges for experimentation. So what do we do about data at Airbnb? So we think of data at Airbnb as the voice of the customer. So we follow the life cycle of the customer. We look at when they come to our site, when they search, when they book, when they review. We try and use data to understand how people are moving through this process, how we can improve the process, can we predict what will happen, can we use those predictions to make the experience better. And so data is really important for understanding all of the different parts of the customer experience. We have a division of labor at Airbnb when it comes to data. This has been an evolving system. As I mentioned when I started, there were 5 of us, and we actually did a lot of these pieces, but we've now grown to actually segment it out. The first bit is the product and the engineers logging the data. Then we have a data infrastructure team that takes the data and makes sure that it's being logged correctly, that it's hitting our system. We have a data engineering team that then helps to extract, transform, and clean the language, basically the ETL, to clean the data. And then the data science team takes on the actual analysis, obviously partnering with all of these. We work very closely with engineers to build out our experimentation framework and make suggestions to the product. So this is kind of the structure right now of data at Airbnb. So as you can see, experiment design is huge and a big part of what we do. And it's a big part of how we make decisions at Airbnb. And the tricky thing is, though, that there are actually some features of our system that make experiments a little more difficult than you might think at first. So a couple of those features are, first of all, most users are not logged in while browsing. And this is something to keep in mind as we go through the future slides. Trip planning has a longer time scale than many other types of interactions. So many of our users will come to Airbnb for the first time, and it'll take them weeks to actually decide where they want to stay and then book the place. So this isn't something where you launch an experiment and you instantly get an answer for some types of experiments. The other thing is that people often come in through using different devices. So they'll check Airbnb on their phone, they'll check it on the web, and so that feature of our system actually leads to some interesting problems with experimentation. Finally, it's a marketplace with finite supply. And so it's really this ecosystem where users are impacting each other. Each listing is unique. There's only one of them. You can't buy more than one. And so this also leads to some challenges when it comes to experimentation. So this is just some context about Airbnb, and these are going to come up now as I go through kind of real-life examples of experimentation. First of all, though, we need to understand why we would use an experiment. So often when you're at a company, people will want to launch features, right? So they'll launch a feature, and then people will look at data. And so, they're using data, great. And you might look at some outcome like bookings over time. And in this particular case, the feature was launched in May, and we actually see bookings increase over time. So naively looking at this, you might think, oh, like this feature led to the bookings increasing. And this is a classic case of correlation not implying causation. People do this all the time, though. And the real issue is you don't have a counterfactual, right? We don't know what would have happened if we hadn't launched that feature, so we can't actually link that feature to the changes in the metrics that we see. What if the world without the feature looked like this blue line? That would completely change our conclusion about the impact of that feature. That would imply now that actually the feature launch made our bookings go down. So this is where we use experimentation. It's to get that counterfactual. So you want to have a control group and a treatment group so you can compare the state of the world with that treatment to the state of the world without it. And this can be incredibly powerful. And you can use it actually not just A/B testing on your website in a traditional way, but across your company. So just to go through one quick example, at Airbnb, as we've been experiencing this hockey stick growth, we've had a lot of operational efforts to increase growth. One of those efforts was actually having agents in countries all over the world calling our hosts and giving them suggestions about how to improve their listing. So as you could see on the page, when someone clicks onto the listing, they have all this information. And so the thought was that if we could help guide hosts to put the right kind of information on their listing, that would be a good thing. Well, and it turns out that the hosts who were called by these agents actually were doing better than the hosts that weren't called. So the naive estimate was that, the calling makes a difference. Well, again, correlation doesn't imply causation. So we launched an experiment, and we actually withheld 10% of the hosts to be able to be called by these agents. And we found that there was actually now no effect of the agents calling. And so what had been happening was that the agents were actually calling the hosts that were already really good. And so they weren't going to be making much of an impact, but it then looked like they had a big impact. And so this helped us to understand how to actually improve this program so that it would have the impact that we wanted it to have. And we would not have known that if we had not run the experiment. So bottom line, if you can do an experiment, you should do it. It will change how you think about your system, and often things that you think will be really positive might not be, and you'll only know that if you run an experiment. So I want to talk now about some lessons we've learned about doing experimentation, because what we've learned is actually it can be a lot more complicated than it initially seems. So the first lesson, number one, is to make sure it's random. So the whole premise of an experiment is that you're randomly assigning users to the treatment and control so that the two worlds look the same. This is a little more tricky than you think. So here we have some users, and in the ideal world, we would have some function that would randomly assign them, and it would look something like this, evenly distributed. So the very first thing that people often think about when they're trying to decide how to randomize is they think, well, let me find some sort of number, like, say, the user ID. That seems random. And let's assign users to a treatment and control based on that user ID. And maybe we'll use something like a mod function, right? And we'll do user ID mod 2, and if it's a 1, then they're in the treatment, and if it's a 0, they're in the control. And this is essentially saying, is the user ID even or odd, and assigning them to the treatment based on that. And this seems like it should work, right? Because in theory, your user IDs are random, and you're assigning 50 to the treatment and 50 to the control. And this will work if you want to run one experiment in the world ever. But if you want to run more than one experiment ever, you should not do this. And let's go through why that's the case. So let's imagine that you're at Airbnb, for example, and you have lots of different people working on your product. And you have an internationalization team, and they want to translate the text on your Book It button to be in the local language, because they think that will make a really big impact on bookings. Now people are able to understand what the button is saying, and they can then click on it and book. And so you want to run this in an experiment to get the impact of translation. Now, simultaneously, you have another product group that has decided that that particular placement of the Book It button that now you want, they think it's not going to work. So they decide to remove that button entirely. So they both decide that they want a 50-50 experiment, and so they use user ID mod 2 as their treatment assignment function. And this seems really nice, right? It's super simple to implement. It's really easy to understand. You know immediately which user is in the treatment group and which is in the control. But what does this actually lead us to? So you'll see now we have user ID 28394. And in the kind of local language experiment, they get assigned English, not the local language. In the button experiment, they get to see the button. Now we move to our next user ID. That's odd. So they get the local language and no button. Now we go to the next, local language, no button, even English has button, even English has button. And the curious thing that happens is that if we actually look at a kind of crosstab of these two experiment assignments, we find that everyone who's assigned to the English treatment, where the button text is in English, have a button. And everyone who's assigned the local language actually has no button. And this will lead to some incredibly interesting results where the translation of your button to the local language leads to 0 bookings. And so this is a really big problem because they're perfectly overlapping, and that treatment of the button actually removed the button. So this is like a very extreme case. It often is much more subtle than this, and there isn't quite this exact overlap. This makes it really obvious. And basically, what I'm trying to say is, like, just don't do this. Don't use the user ID to assign treatment groups. So the solution that is also pretty simple is actually to do a hash function of your user ID and some sort of experiment identifier that's also random and not overlapping with anything else. And we use the experiment name because those are always distinctive. And this was working for us for a while. We used a standard hash function called SHA-1. And that was great, and we didn't have this overlapping problem. We could run lots of experiments and not worry that there was this kind of cross-contamination. More recently, we tried to do something where we realized we wanted to run some experiments on the front end, and we wanted something that was a little simpler to implement, not as heavyweight, and so we went with this fnv1a hash function. And this seemed like a good idea at the time. We said, oh, we're hashing the user ID and the experiment name, it'll be fine. And it was not fine. So what happened is actually this particular hash function, the plot on the right is showing, the colors are basically showing, you could think of it as the randomness of the bits. And what this is saying is that actually those last few bits are not random for the fnv1a hash. And so we ended up with the same situation of kind of overlapping treatment groups. And the way that we figured this out was actually by doing simulations. And so this is a really important lesson where anytime you're trying to implement something like this, you want to actually kind of simulate the system that you're creating through this experiment assignment to make sure that problems like this are not happening. So we caught the problem, which was good, and switched to another lightweight hash function that did not have this property. The other thing that you might do to check your randomization is to look at plots like this. So if you see that all of your treatment is in Greenland and all your control is the rest of the world, that's probably a problem for your randomization. So what you want to do is take observed covariates that are pre-treatment and see if the treatment assignment predicts those covariates. So essentially seeing if those are correlated. And if you see that there are many cases where there is some sort of very strong correlation, that could be a flag to you that there's something wrong with your randomization. So in conclusion, for lesson 1, at the very start of an experiment, you're trying to assign users, there are things that can go wrong. So first of all, you want to not just assign based on the user ID, but do a hash function of the user ID and an experiment name. And also be really careful about what hash function you pick and do tests of that. And then finally, to always be doing kind of randomization checks to make sure that there's not something wrong with your system. So that's, at the very start, what you do. So say you get that all right. You're not home free yet. So in Airbnb land, we talk about accounting for the mixed group problem. And I'm going to talk to you now about what I mean by that. So 2 years ago, we had this really awesome new product called Neighborhoods. So we had people go around the world and get information on neighborhoods. So, for example, for San Francisco, we'd have the mission. What are some characteristics of the mission? And the idea was that this would help people to understand where they wanted to go in the city that they were traveling to. And like many product launches at tech companies, people will often want to launch to everyone because, you can have this big splashy launch, have lots of press around it, and you don't want some users to not get the treatment. As we explained, then you don't necessarily know what the impact of the change is, and so we came up with a solution of launching the treatment to 75% of users instead of 50-50, so that most people would get the new treatment of this neighborhoods page, and this was actually, this replaced our homepage with this neighborhoods page, and then 25% wouldn't get it. So we did that, and we found some amazing results. It turned out that the neighborhoods homepage increased bookings by orders of magnitude. People were much more likely to book. And being data scientists, we kind of questioned that finding. This seemed like maybe it wasn't quite right. It's not it'd be amazing if it were true, but it was something that we were a little concerned about. And luckily, at the same time, we had been running more stress tests of our system. So one way you can test your system is by running AA tests. And AA tests are where you have a treatment and control group, but they're actually the same thing. So you actually give the same treatment to the treatment group and to the control group. And so this is a really nice way to test if your system is working how you expect it to work, because if you then compare the treatment to the control, there should be no effect of the treatment because it is exactly the same as the control. So we had been doing that, and we found some very interesting results. So we found that in cases where the treatment and the control group assignments were to equivalent percentages, so 50-50, 33-33, 25-25, we saw what we expected, where there was no difference between the treatment and control group. But in the cases where we had something like the neighborhoods launch, where it was 75-25, we saw really big treatment effects. And again, keep in mind, this is an AA test, so the treatment and the control are the same. This is really strange. So what was going on? So this prompted us to kind of think a little bit about our system and how we were thinking about experimentation. So as I mentioned at the beginning of this talk, a lot of the users who are using Airbnb are not logged in. So an example of a user trying to book on Airbnb might look like something like this. So I'm a user, I'm at home, I'm thinking about going on a trip, I come to Airbnb and I do a search, and I have no user ID. So the thing is now, how do we assign the treatment group if there's no user ID? We actually use the cookie that's associated with that, and we assign based on the cookie if someone's not logged in. So we would do that, and in this case, that user would now, with that cookie, be assigned to the control. Now that same user now goes to their office, and they look again, and they're like, okay, now I'm ready to book. And actually, they have a different cookie now. They're on a different device, and they see the treatment. At this point, they now log in, and so we can now link their user ID to this treatment of the neighborhoods page. And then later, they actually go home, and they log in again on their home computer to send a message to their host. And then we see that, like we showed them the control. Now we can link their user ID to a cookie that saw the control and to a cookie that saw the treatment. And so they were actually seeing both. And this is a big problem because that means that they're not really in one treatment versus the other. They saw both of the treatments. And so how do we think about now attributing a treatment effect to someone who is in the treatment and in the control? So that's a big problem, and it actually is what explains the effects that we were seeing for 75-25. So I want to go through why that's the case. So in a case where there are equal sample sizes, so say we have 4 conditions and we give 25, 25, 25, we split it equally between the two. In each of those buckets, there will be a fraction of users who are in this mixed group that we see from our data have seen both the treatment and the control. And there's actually an equivalent distribution across these groups because we've done this randomly, and so we have no indication that they're more likely to be in the mixed group. Now, if we have not equal sample sizes, in this case now, we see that we have the same kind of blue size mixed group in the 25% group. But now we actually have the 3 buckets now into the 75 group, and we actually only see one of those small buckets. Because these people who would have been mixed group, they're not seeing another treatment, they're seeing the same treatment now, because the 75 group is much bigger. And so the issue here is that actually those mixed group users that we had been seeing before, they are a small fraction of visitors, but they're actually a really large fraction of our bookings, because the people who are booking are actually browsing on different sites and are not logged in before they start to book. And so the reason that we were seeing such a big effect from the neighborhoods launch, which was that 75 group, was because they had this group of mixed group users that we hadn't been taking out because they had actually not seen both the treatment and the control. And so this was something that we discovered by doing AA testing. So this makes a really big difference. So if we then relaunched the neighborhoods experiment as a 50-50 experiment, and we actually saw that the neighborhoods homepage decreased bookings, which we kind of figured was going to be the case. And this was not necessarily a sign that we should not do the neighborhoods launch, but it actually led us to then dive further into what about the change to the neighborhoods page had impacted bookings. And we found that part of the reason was actually that we had now obscured the search bar, and it was much harder to find. And so if we just moved the search bar, that actually might lead to more similar bookings numbers. So again, here's a case where something seems really simple, but actually, using data science, looking into the data helps you to get to the right answer and helps the company to make good decisions. Okay, so again, you can use equal treatment and control groups to account for this problem, but this is actually an area of active research for our team because, as I mentioned, those mixed group people are a large fraction of our bookings, and so we want to come up with a better way to deal with them. So any ideas, let us know. Okay, so last and final lesson, change the level of randomization to account for cannibalization. So what do I mean by that? Well, so cannibalization is a bad thing for experiments. What do I mean by that? So it all comes down to SUTVA, the stable unit treatment value assumption. So this essentially says that if you're going to run a unbiased randomized controlled trial, the treatment assignment of one user should not impact the outcomes of the other user. Because if that is the case, then you might see differences in the two groups. So what's kind of a real-world example of this? So Airbnb has a professional photography program. So we actually have photographers all over the world, 3,000 photographers, taking professional photos of listings. And the idea here is that when a listing has really great photos, people will be more likely to book. And so this program is based on this assumption that really nice photos make people more likely to book. And so, we really love this program, and we feel like it's been really good for our site. But, we also want to know what is the actual value that this brings to our company. And that's a question that people came to our team with. So the issue here is that hosts sign up, and there's a button that they can click to request professional photography. And so if you compare the hosts that get professional photography to the hosts that don't, it looks like the hosts with professional photography are doing much better because they've actually opted in. So it's that classic selection problem, and we really can't compare the two groups. So you might think, well, why don't we just run an experiment where we assign 50% of the hosts to get, or whatever percent, to be able to click on photography, and 50% to not. And the problem, though, comes from cannibalization. So say I live on Dolores Park, and I get assigned the treatment to get professional photography, and I get professional photography. And my neighbors are in the control group, and they don't get professional photography. And then someone comes to our site, and they look at all of our listings, and they book mine because I have the nice photos. Well, the thing is that maybe in that other world, actually, they would have booked my neighbors. And so I've just kind of taken that booking from my neighbor. But Airbnb hasn't gotten more bookings because of the professional photography. So this is kind of the question that we now are grappling with, where if we did this experiment, we actually wouldn't get the right answer for what's the value of photography to Airbnb. So we took a step back, and we thought about a way that we could solve this problem. And one solution that we came up with is actually to change our level of randomization, to get rid of this kind of spillover cannibalization problem. So the world that we're in now is where, if we were to randomize markets, we might see that a place like Portland being assigned to get professional photography wouldn't really impact the outcomes of Auckland, New Zealand, because we see in our data that people never search for the same trip to those two places. And so then you have this situation where it is actually independent, and we can understand the value of photography to our system and don't have this kind of cannibalization spillover effect. And as you might expect, this changes our understanding of the value of this program. So it's important that we kind of kept this in mind and did the experiment at the right level. So one problem with market level experiments is that we have not as many markets, right? So it's a smaller sample size, and we often have some markets that are more distinctive. And so say you have New York City in your treatment group, that will really change your results. And often you also want to know, maybe I just want to launch in one market, right? And I don't want to launch across 50 markets. How would we understand the effect in that case? And so one solution that we've come up with is what's called using a synthetic control. And so this is a reference to the paper that we kind of got this from. But the idea is that we would assign the treatment to a market, and then we would create a control based on kind of a weighted average of other markets, so that we end up with a control comparison that's much more similar to our treatment market. And this gives us more precise estimates, and it also makes it possible for us to launch in like one market, for example. So how does this work? And another kind of neat thing about this is, as Anna mentioned, my background's in education. And so in the field of education, you often can't randomly assign students to treatments and control. And so you kind of have to come up with other ways to get cause and effect. And this was actually something that I'd heard of in that context. So it's a kind of interesting case of where having people with different academic backgrounds on your data science team can actually be really positive, because you can draw from those different experiences to kind of come up with the best method to tackle a problem. Okay, so some of you who know Airbnb might have heard about how this summer we actually rebranded our site. So we did a redesign of the entire website and also got a new logo, which got a lot of publicity, so you should check it out. It's very lovely. But one part of that is, as I mentioned, we redesigned the whole site. So this was the old listing page, actually, and this is the new listing page. And this is like a key page in our website, because this is where people are looking for information and trying to decide whether to book the place. And so, we wanted to launch this big rebrand, but we also wanted to know what was the impact of these changes on our bottom line. And so this is a case where people are not logged in. We've got mixed group problems. We've got cannibalization. So we decided to use the synthetic control method to try and get at the effect of the rebrand. So how did this work? Basically, what we did is we started off by clustering markets based on their seasonality patterns. So we ran a Poisson regression and got the coefficients from that and did k-means clustering. We came up with basically 4 different clusters. So you can see that there are some markets where their peak season is in June, and those are kind of summer markets. We have curves with the opposite effect. Those are more winter markets. And we start with that because that actually makes the synthetic control work a lot better if you start with groups that have similar patterns. So then we did this kind of creation of the synthetic control. And what you end up with is something like a market like Aspen and Vail then being a weighted average of other markets in our system. So Aspen and Vail is 0.43 Tahoe City, 0.37 Salvador, 0.17 Gran Canaria, and 0.07 Southern Alps. And so then you can look at the difference between the actual and the synthetic control over time. The line indicates when we launched our treatment, and you can see what happens after the treatment. So in the case of our rebrand, we looked at a plot that looked something like this, and we saw that even though it's not super large, in our world, actually this means that there were significant treatment effects. And so this is how we understood that actually this rebrand had some positive benefits to our bottom line, which is really cool that we were able to know that. So in conclusion, in cases where you have cannibalization, think about this think about the level of randomization, so try market, and you can also try a synthetic control. Okay, really quick before I leave, just a couple last points of pitfalls to avoid. So first of all, pick your metrics ahead of time to avoid cherry picking. This is another thing that happens often in the real world, where there are lots of metrics that you could look at after an experiment, and you'll probably find one that has a statistically significant impact. So don't do that. Pick it ahead of time. Do power analysis to determine actually the sample size you need and the length of time that you need to run an experiment. Check for heterogeneous treatment effects. This can be really important for understanding the impact of your experiment. So you might find that people using IE8 have a really negative experience with some change, and other people don't, and you want to know that. So make sure that whenever you run an experiment, you take that extra step to break down the treatment effects by relevant segments. Okay, so finally, in conclusion, run randomized experiments. You will be amazed by what you find. When you do, make sure that you're really careful about it. Make sure that the randomization is working as you expect. Stress test your system with AA tests to avoid the mixed group problem. Change the level of randomization if you do have this cannibalization issue. And kind of lastly, something that I didn't talk about is, don't reinvent the wheel every time. Actually, a big thing that our data science team has worked on, along with our data infrastructure team, is to build out an experiment reporting framework that actually corrects for all of these problems and helps us to run many experiments in an automated way and visualize the results and stuff like that. So that's also really huge once you get to that point. So that's all I got. Thank you.
Sure, there are questions. Yeah. Okay, there's some back there too.
Yeah, hi. Very, very nice presentation. So I'm curious. I'm not a data scientist, so I'm just curious about like when you talk about this A and B kind of test. So do we also have to do you take care of or you need to take care of the demographics like they do in the market research? Is that relevant? And another question is, what is the turnaround? I mean, when you run this experiment, usually you want to go to try it out in the real life. So what is the difference between the time you run this experiment and then you really implement that?
So yeah, to answer your first question, what do you do about demographics? So one of the really nice things about a randomized control trial is that you use the randomization to have a kind of equal split between different groups, right? And so in expectation, we would expect that our treatment and control group would have equivalent proportions of different demographic groups. And those are things that you can observe. There are other things that you can't observe, and that's why you use randomization to balance those out too. But, as I mentioned at the end, you might be interested in heterogeneous treatment effects. So maybe you think that the effects are different for those different segments, by gender, men or women. And then you can actually, look for those effects as well. And if you really care a lot about that, you could do some sort of blocked random sampling to care about that. But yeah, there are ways that you can get at that. But at its very base level, the idea behind the randomized experiment is that you will have balanced treatment and control groups by doing this random assignment. Should I answer, what was the second question again? The time frame. It depends on the experiment. So that's why you do what's called power analysis, and that's where you look at what you expect the treatment effect to be, and you think about what sample size and what power you need, and that will help you to determine how long you want to run the experiment for. So it really depends.
Okay, there's two questions back there.
Yep.
Hi, so we are taking a course in field experiments, so this is very relevant, so thank you for your talk.
Excellent. Perfect.
So could you explain the context behind the synthetic control and that concept a little bit? That is new to me, the synthetic control.
So I guess maybe this is the best way to do it. What would be the best way? Well, so the basic idea is that you want to create a control group that's very closely matched to your treatment group. And so oftentimes, if you're doing something like a market level experiment, you won't have in the world anything that's like similar. And so you will need to kind of create a control group by doing a weighted average of other markets, and that ends up with a group that's very closely matched. So in this example, if we hadn't done the synthetic control, we might not have had anything that was similar to the treatment market without doing that weighted average.
And you check that by covariate balance, so you check that your synthetic control is synthesized properly. Your test will be the AA test, or you do the covariate balance check?
Both.
Yeah. Okay.
So I had a question about the mixed groups section.
Sure.
So the proportions of people who are in the mixed groups to the rest of the people are the same in 25-75 versus 50-50, right? Like in the idea, yeah.
I'll go back to the slide.
Okay.
Yeah.
So the proportion of like blue and red on the 75 to the gray is the same in 75 as on the right part, onto the left. But there's still a problem right? So what is, even though it seems like the mean would be the same, if you had, it seems like there's,
So the issue is that red group, they don't actually see a different treatment assignment, right? They're no longer a mixed group because they're seeing that same treatment, because that treatment is actually 75% of the population. So that's kind of where the issue comes in, where they aren't identified now as mixed group users, whereas in the past they would have been.
I see, okay, thank you.
Yep.
Hi. I think you have some really neat experiments, but one of my questions is, you're looking at something that's constrained in your quantity. So either they can book or it's already been taken, it's available, but you have one room. And there's this concept of unconstrained demand. So maybe people wanted to book something, but this isn't captured in your data because we're looking at actuals. Do you have any demand tracking data or any kind of data that gets at the percentage of closed so you can estimate unconstrained demand and use this in experiments?
So one thing that I didn't really mention, but whenever we do experiments on something like the booking channel, we also, if we change the search ranking algorithm, we're not just looking at bookings. We're looking at the entire funnel of metrics usually to kind of see what the impact is on each of those stages. Again, thinking about a marketplace, I talked a lot about the spillover effects, and so that's where you want to think about changing the level of randomization if you think that could be happening.
Last question.
Can you talk about running multiple experiments concurrently and good safeguards against unexpected interactions?
Yeah, so I think that's where the kind of testing your randomization is really important. So kind of running simulations where, let's say you're going to run a lot of different experiments, and you can kind of run simulations of the treatment assignments, and then you can see, do they look balanced? Do we see kind of non-random overlap between different experiments? And really just test your system through the simulations, and then also, once you're actually launching things, also through AA tests. So yeah, just I think being really careful at every step of the way that you're kind of sanity checking what's happening.
Great, thank you so much.
Yeah.